In the chapter 3 to 4 test, we're going to be starting by solving linear equations. So starting with number 1, we want to solve 8x plus 11 equals 15 for x. So to do that, we start by subtracting 11 on both sides. That gives us 8x equals 4. Then we can divide by 8. X equals 4 over 8, but 4 over 8 simplifies to 1/2. For number 2, we're also solving for x. We have to start by distributing. So I distribute the 5, and I'll get 5x plus 35. I distribute the 6, I get 6x minus 30. Here I'm going to subtract 5x on both sides because the 6x is bigger than the 5x, so I'm moving it to the right. And that gives me 35 equals x minus 30. And I add 30 to both sides. And that gives me 65 equals x. So answer choice B in this case. Now moving on to inequalities. For number 3, in order to solve it, I'm going to actually use my SADMET properties. I'm going to subtract 20 on both sides first. When I do that, I get 5 times x minus 1950 is less than 10. Then I divide by 5. So now I have x minus 1950 is less than 2. I add 1950 to both sides. I get that x is less than 1952. So notice that to write this in set builder notation, I say the set of all x such that x is less than 1952. Answer choice C. Now for part 4, or question 4, we need to isolate the x, but there's a fraction here. So I can work with the fractions or I can get rid of them. In this case, I'm going to multiply through by 2. When I do that, I get 10x minus 10 is greater than or equal to 5. Now I add 10 to both sides. 10x is greater than or equal to 15. And I divide by 10. X is greater than or equal to 15 over 10, which simplifies. So 15 over 10 as, well, 15 divided by 5 and 10 divided by 5 tells us x is greater than or equal to 3/2. And again, we're going to write this in set builder notation. So we're going to write it as the set of x such that x is greater than or equal to 3/2. Answer choice C. For question 5, we want to use the graph to solve the equation and the inequality. So notice that there's technically 2 questions here. So starting with y1 equals y2. Well, that happens when our 2 graphs intersect. And that's going to happen right here. What you'll notice is at a weird spot for the y's, but that doesn't matter because we're looking for the x value. So notice that that happens at x equals 3. So we can eliminate answer choices A and C because they say x is -1 or 4. Now, the next thing we want to do is figure out how to solve y1 is less than y2. So notice that y1 is less than y2 when the dashed line is below the solid line. The dashed line is below the solid line right here. Now, since that is to the right-hand side of the point where they intersect, we can say that that happens when x is greater than 3. Answer choice D. Now, part 6 is a 3-part inequality. We're going to start by getting rid of the fraction. To do that, we're going to multiply through by the denominator, which in this case is 3. So that gives me -12 is less than 10 minus 8x is less than or equal to 15. Now I'm still trying to get x by itself. So I'm going to subtract 10 on all parts. That gives me -22 is less than -8x is less than or equal to 5. Now I'm going to divide everything by -8. Now -22 over -8 gives you a positive 11/4. The middle will be x, and the last one will be -5/8. Notice that the less than becomes greater than, and less than or equal becomes greater than or equal. Now, my order here is backwards, so I will rewrite it to be -5/8 is less than or equal to x is less than 11/4. So it's always least to greatest. That means I can write a bracket with -5/8 because it's or equal, and 11/4 has a parenthesis. That gives me answer choice D. Now in question 7, we have an absolute value equation. So I'm going to go ahead and clear off some of my work here so I have some space. And for this question, I need to first get to the absolute value by itself. So I'm going to subtract 4 from both sides. Okay, that gives me that the absolute value of 2m plus 8 equals 9. Now, I can set the inside of my absolute value equal to plus or minus the other side. So 2m equals -8 plus or minus 9. And I could divide both sides by 2. M equals -8 plus or minus 9 over 2. -8 plus 9 is 1, and 1 divided by 2 is 1/2. -8 minus 9 is -17, so we get -17/2. That is answer choice D. For question 8, we're told that the absolute value of x equals -0.57, but an absolute value can only ever be a positive number, so this is no solution. Now, for problem 9, we want to find the sum of two numbers is 40, and the difference is 10, so we want to find the two numbers. So we know x plus y, the sum is 40, and the difference, x minus y, is 10. This is a system of equations that is set up for elimination. So I'm going to add down, and I get 2x, the y's cancel, and that equals 50. So I divide by 2, that tells me x has to be 25. So 25 plus y has to equal 40, means that y is 15. So my numbers are 15 and 25. Answer choice C. Now, for number 10, I'll go ahead and graph it here and we'll look at the answer choices in a minute. You can see that y is greater than or equal to 5x. That means my slope is 5 over 1. And my y-intercept, because it's plus nothing, there's nothing there, is 0, 0. So I plot the point 0, 0, and I count up 5, right 1. You can count up 5, right 1 as many times as you like, or you can count down 5 and left 1. That's valid too. You'll connect the dots with a solid line because it's greater than or equal to. Now I'm going to test a point. Okay, so I can't test 0, 0 because that's on the line. So I'll test, let's do 2, 0. When I test 2, 0, I get 0 is greater than or equal to 5 times 2. 0 is greater than or equal to 10, which is false. So I don't shade on the right side where 2, 0 is. I shade on the left side. And when I look at my answer choices, I say that must be answer choice A. Now, for question 11, we want to graph the solution of the system. So we're going to start with our top inequality, which I will do in red. Okay, so there I'm going to say x equals 0, and that would tell me that 2y equals 2. So y equals 1 tells me 0, 1 is one of the points on my red graph. I'm going to repeat this process with y equals 0, and that's going to tell me that x equals 2. So I have the point 2, 0 for my red graph. So I have 0, 1, I have 2, 0, and because it was a greater than or equal to, I'm going to be able to connect these with a solid line. Don't forget your arrows. And I still need to figure out which way I would shade. So I'm going to test 0, 0. When I test 0, 0, I get 0 is greater than or equal to 2, which is false. So I know that that means I'm going to shade above the red line. Now for number 11, for the second inequality in number 11, I'm going to do it in blue. So to graph it again, I'm going to find intercepts. So when x equals 0, it becomes negative y equals 0 or y equals 0. So that's the point 0, 0. And when, well, actually, funny story, that doesn't come out. That's the same intercept for both x and y. So I can't plug in y equals 0 and expect to get another number. So I can either put it in slope-intercept form, or I can just pick another value. Like, let's say I want to set y equal to 1. Then I get x minus 1 equals 0, which means x equals 1. So I can also say I have the point, 1, 1. Okay. So you'll notice here, I can't test 0, 0 because 0, 0 is on the line. So I'm going to test something else. I will test 1, 0. When I plug that in, I get 1 minus 0 is less than or equal to 0, or 1 is less than or equal to 0, which is false. So I can't shade on the side of 1, 0, so I have to go to the left of the blue line. So I need to go above the red line to the left of the blue line. And when I do that, and I look for that combination, it's going to shade in this piece here, which you can see is answer choice C. Now on to the short answer questions. Page 5 has short answer questions that involve systems of equations. All systems of equations have to be solved the way that they're asked for and must be answered using a point. So let's start by graphing. Y equals negative x plus 3. Well, I can tell you that my y-intercept is the point 0, 3. And my slope is negative 1 over 1. So I plot 0, 3. And from there, I'm going to count down 1 and right 1. Then I can connect these dots. And again, you want to do this with a straight edge to make sure that it lines up perfectly. And then my second one is 3x plus 7. So my y-intercept here is 0, 7. And the slope is 3 over 1. So I count up 7, 1, 2, 3, 4, 5, 6, 7. And notice if it goes off where like you can't graph the y-intercept, you can always pick another point by like plugging in x equals 1 or x equals negative 1 to find another point that works. Okay? And from there, normally I would count up 3 and right 1, but you'll notice that goes off the page. So remember, up 3 and right 1 is the same thing as going down 3 and left 1. Okay, that would end up on the same line. So we'll count down 3 and left 1. And when we connect those dots, you can see that these do intersect right here. So that is the answer negative 1, 4. Okay, that would be our point answer. In question 13, we want to use substitution. So that means that I am going to take the y in the second equation. I'm going to replace it with what they tell us in the first equation y is equal to. So that means I have x minus parentheses, negative 1 minus x equals 7. Then you have to distribute the negative. X plus 1 plus x equals 7. I'm going to combine my like terms. X and x gives me 2x plus 1 equals 7. I subtract 1 from both sides. 2x equals 6. I divide by 2 and x equals 3. Once you know your x value, you can go back to find your y value. So y equals negative 1 minus x, but I'm going to replace x with 3. So y equals negative 4. That means my answer is the point 3, negative 4. Question 14 required that you used elimination. So I look at this and I try and decide what is the easiest thing to get rid of. And I'm going to choose to get rid of the x's, because if I multiply through the first one by 2 and the second one by 7, They're already opposite signs and it comes out nice. And it is a little smaller than if we multiplied through for the y's. So my first equation is going to become 14x plus 16y equals 106. My second equation is going to be negative 14x minus 35y equals, and then 26 times 7, 7 times 6 is 42, 7 times 2 is 14, plus 4 is 18, so that's negative 182. Don't forget to multiply the entire equation when you're doing this. Now when I add down, my x's will cancel, and that's going to leave me with negative 19y equals negative 76. When you divide both sides by negative 19, you're going to get that y equals 4. Once you know your y value, again, you still need to go back and find your x value. So 7x plus 8 times 4 equals 53, means 7x plus 32 equals 53. 7x equals 21, means x equals 3. So my point here is 3, 4. On the last page, all we wanted to do was graph. Okay, so x is greater than or equal to 2. Well, this is a vertical line, and it is a solid vertical line. Okay, so I'm going to go ahead and switch to a different color here. So we have x is greater than or equal to 2. We'll go right there. And then we can see that the way we shade in this case would have to be to the right because we're greater than, okay? But you can also do a test point. You can test 0, 0. When you do that, you get 0 is greater than or equal to 2, which is false. So that also tells you that you have the shade on the other side. Now, for the other question down here, y is less than negative 3. And apparently my line hung out. There we go. Okay. Y is less than negative 3 is a horizontal line that's dotted. So it's a dotted or dashed line through negative 3. And if you tested 0, 0, you get 0 is less than negative 3, which is false. So that also shades away in this case, which would be below.